In this video, we're going to discuss the correlation coefficient. We will be able to use the calculator to calculate the correlation coefficient, which we represent as R. R is always between -1 and 1 or equal to -1 or 1. If R is equal to 1, that means that the line of best fit for the data is a perfect fit for the data. There's a perfect positive correlation, an exact positive correlation. If R is equal to -1, it also means that the line of best fit is a perfect fit, but in this case, there's an exact or a perfect negative correlation. If R is around 1, or let's say R is equal to 0.9 or 0.8, that means that there's a strong positive correlation between the variables. That means that the line of best fit doesn't pass exactly through each of the points of data, but it's very close. If R is around -1, let's say it's -0.8 or -0.9, that means that there's a strong negative correlation between the variables, where the line of best fit doesn't pass exactly through the points, but it also passes very close, but in this case, the line is going to have a negative slope instead of a positive slope. If R is either equal to 0 or very close to 0, that means that there's a weak correlation between the variables. If R is around 0 but it's negative, let's say it's -0.05, then there's a weak negative correlation. If R is a positive number that's very close to 0, like 0.03, then there's a weak positive correlation between the variables. If R is somewhere in between 0 and 1, let's say R is around 0.5, then there's a moderate positive correlation between the variables, which means the line of best fit doesn't pass through the points or even near the points, but it's not very far off. If R is around -0.5, somewhere in between 0 and -1, there's a moderate negative correlation between the variables, which means the line of best fit has a negative slope. It doesn't pass through the points or near the points, but it's not a terrible fit either. So in order to have the calculator calculate for us the correlation coefficient, we're going to have to turn the diagnostics on. So we're going to press second 0 to go into the catalog, and we're going to have to scroll all the way down to diagnostics on. When you see diagnostic on, you're going to press enter, and then press enter again. That's all there is to turning on the diagnostics. Now your diagnostics are on. Now we're going to put in some x and y values, and we're going to have the calculator calculate for us a line of best fit. We're going to press stat, edit. Just like we would calculate any line of best fit, we're going to enter in our x values into L1 and our y values into L2. And then we're going to press stat, calc, scroll down to lin-reg, linear regression, press enter. Our x-list is in L1, our y-list is in L2. We don't have a frequency. Let's store the regression equation in y1 so we can see how it looks when it's graphed. So we're going to press alpha, trace, and enter over y1, and scroll down to calculate. Notice now that when the calculator calculated for us the linear regression, it also calculated for us some R value. This is R, this is what we've been talking about. This is the correlation, this R is the correlation coefficient. Since this R you could see is very close to 1, 0.98 is very close to 1, the line of best fit for this data is going to be a very good fit. And let's see how this looks. So we're going to press zoom 9 to see the points graphed and the line of best fit graphed. In order to see the points, we have to press second y equals, so we're in stat plot, press enter over the 1. We have to turn the plot on. The type is going to be a scatter plot, the x-list will be L1, the y-list will be L2, the mark could be that dot, and the color blue. And then zoom 9. There are points, and there's the line. You can see that the line passes through some of the points, and it's very close to the rest of the points, and therefore it's not a perfect correlation, but it's very close. Let's look at another example. Let's put in different points now. We're going to clear out our list 1 and our list 2. For our x values in L1, we're going to put in our y values. Now we're going to have the calculator calculate for us the linear regression. So stat, right arrow to calc, scroll down to LINREG, linear regression, press enter. Our X list is L1, our Y list is L2. Let's store this in I1. And then we're going to press calculate. We don't need to turn diagnostics on. We already have diagnostics on from the last problem that we did. And diagnostics are going to be on your calculator forever, even when you turn it off, unless you actually go into catalog and press diagnostics off. We're going to press calculate. The calculator calculates for us the linear regression, and we see that R, in this case, is 0.174. It's very close to 0, and therefore there's a very weak correlation between the line of best fit and the actual data for this graph. Let's see how it looks graphed. Our plot is still going to be on from last time because we didn't turn it off. So all we have to do is press zoom 9. The points will graph, and so will the line of best fit, because we have that in y equals from when we put that in when we were calculating the linear regression. That's the line of best fit, and we can see that it doesn't pass through, it only passes through one of the points, and it's very far from the rest of the points. That shows us why the R value is very close to 0. There's only a weak correlation between the line of best fit and the actual points of data. And the calculator tells us that this blue line is the best fit, and even if we try other lines like this, no lines are going to be a good fit for the data, and the calculator found that's the one that's the best, even though it's not such a good one. Although you can use the R, the correlation coefficient, to tell you if data is a good fit, let's say you have a word problem. Let's say we have a graph and the x-axis represents the rainfall per month and the y-axis represents the sale of boots in that month. And we have a plot and we have a line of best fit. And let's say we have an R value. Let's say we have R is equal to 0.89, which is pretty close to 1. So we know that the line of best fit is a good fit for the data, and we still cannot use this graph and this line of best fit to tell us that there's a causative relationship between the rainfall and the sale of boots. We know that there's a correlation, but we can't tell for sure using this information that the more rainfall there is causes a greater amount of boots to be sold.